This is FRQ 359 now. We're looking at a really good question. I like this question. I feel like it's got a lot on it that they could put on that. If I were picking, I'd be doing one like this, a geometry FRQ that has both geometry and the other way to calculate area under the curve. So let's look what we have. We have a graph of the continued function g, which is the derivative of the function f. So this is the derivative of f. So we're going to use g, though, when we talk about, we're not going to use f prime because they gave us g. The function g is piecewise, so they say, okay, between -5 and 3, it's the graph, and also from 3 to 6, it's this function. They actually give us a function for the second half. Now, why did they do that? I can tell. Geometry is going to help us calculate stuff from -5 to 3 if we have to, and then we'll have to use the function to calculate anything after that because you can't do geometry using that second part. So the first thing I ask you is, if f of 1 is 3, what's the value of f of -5? So this is going to be a geometry area under the curve, I think. So they want f of -5. This is part A. And so that's equal to f of 1. We're using the fundamental theorem of calculus plus the integral from 1 to -5 of g of x dx, which is equal to 3, and then you would have to do a minus because you have to turn that integral around to -5 to 1 of g of x dx. And then we're going to use geometry. Oh, it's not 3. Yeah, it is. It's 3, right? Yeah, 3 minus, okay. And then if you look at, let's just do this area right here. This area is 9, but it's -9. So minus -9. And then we have, let me use a different color, orange. I'll use orange. This part, which is 3/2. So minus, that's negative again, 3/2. And then we have a positive part. I'll just do that in pink, to 1. So that would be 1 because it's 1/2 of 2. So plus 1. So you end up with, let's go back to white. You end up with -9, -10.5, -9.5. So 3 minus -9.5 is 16. 6/2 plus 9/2. Oh, it's 19/2. Sorry. No, wait. Sorry. Yeah, that's 19/2. How did I get? Let's see. What did I forget? Oh, because 9 is not half, so it's, yeah. -9, -10.5, -9.5. Okay, so let's put it in halves is all I did. So let's see. So -9.5 is -19/2. So this would be 6/2. 3 is 6/2. I'll just do it under here. 6/2 minus -19/2 is a positive 25/2. So that's your answer. Okay. Sorry about that. Okay. So part B. It says evaluate just the integral from 1 to 6. Well, so we're going to use the function that's up here, this function, to do that. So the integral from, sorry, get my white, 1 to 6 of g of x is equal to the integral of 1 to 3 of g of x, because remember it cuts 1 to 3. I can do it using geometry, right? Oops, not that one. Not the pink. Just this yellow. I'm going to color in this yellow. This guy. 1 to 3. So you can tell that that is going to be 2 times 2, so 4. Plus the integral from 3 to 6 of 2 times x minus 4 quantity squared dx. All right, now that's equal to 4 plus, and okay, we're going to use u substitution a little bit. So we'll pull the 2 out. We'll go 3 to 6. And let's actually go, that would be, we don't even need to use u substitution, do we? That would be x minus 4 to the third power over 3. All right, and take away that integral. Sorry. X minus 4 to the third power over 3. From 6 to 3. Or 3 to 6. So, let's do that under here. 4 plus 6 minus 4 is, let's pull this 2/3 out. That's easier. And then 6 plus 4, or 6 minus 4 is 2. 2 cubed is 8. So 8 minus 3 minus 4 is -1. And that would be, so that would be minus 1/3. So that would be 4 plus 2/3. This is good practice because you're not going to have a calculator. Or you could use it to check your work. This would be 24/3 plus 1/3. So that is 4 plus 2/3 times 25/3. So that is 50/3. I'm doing something wrong. Plus, maybe not. Let's see, 4, that would be 12/3. So 62/3. I'm supposed to get 10. What did I do wrong? I'm going to stop. Okay, I see where I went. This is supposed to be a third. 8/3 plus 1/3, which would be, let's erase all this stuff after that, is equal to 4 plus 2/3 times 9/3, which is 4 plus 18/3 or 6, which equals 10. Yay! I finally got what I was supposed to get. Sorry about that. Okay, that was B. See if I can do a better job with C. Okay, C. All right, it says for between -5 and 6, on what intervals is the graph both increasing? Okay, increasing. The derivative, it wants to know when the original function is increasing, and that is when the derivative is positive, right? You should know that. And concave up means when is the derivative increasing. So, give a reason for your answer. We're just going to say that. The graph of the original is increasing and concave up from 0. Okay, if we're looking, let's do this in like a color like purple, okay? Let me erase all this stuff on the graph. Okay, so increasing and concave up would be when it's positive, so none of this would count. Positive and increasing, so you would have this bit right here, and then you would have from 4 on that bit right there. So that's going to be our answer. From 0 less than x less than 1. Okay, that's the first little interval. And then from 4 less than x less than 6. Because g of x is greater than 0 and increasing during this interval. Okay? So that's C, and then let's see if we have room to do D. I might have to do it on the other side. D, find the x-coordinate of each point of inflection of the graph. Give a reason for your answer. Okay. Going back and erasing this stuff off my graph, inflection points happen when the original graph, the derivative, changes from increasing to decreasing or decreasing to increasing. That's it. If you're looking at the first derivative, that's all you know. So we have that it's straight and then increasing and then straight and then increasing and then straight. And now none of those work because you have these points of straight with not increasing or decreasing. So none of that would be. But then if you come and look at what happens before 4, it's decreasing, and then at 4 it's increasing. So there's only one place that happens. So you would say the point of inflection occurs at x equals 4 because g of x, which is equal to f prime of x, changes from decreasing to increasing at this point. Okay. So that's D. All right, this is a really good question, and so I hope you understand it. I know it wasn't the clearest but describing it, but I hope you got from it. All right, let's quickly calculate the points, all right? So you got part A was 2 points, part B was 3 points, part C was 2 points, and part D was 2 points. So let's see, 2, 4, 6, 7, 8, 9. Okay, so part 1, you got a point for having the fundamental theorem of calculus right here, plus 1, this integral, f of 1 plus 1 to negative 5. And you got a point for your answer of 25 halves. For B, it was worth 3 points. You get a point for splitting this function from 1 to 3 and then 3 to 6. You get a point for splitting it. You get a point for the antiderivatives. So you get a point for, where's my antiderivatives? Right here. And you get a point for the answer of 10. For C, you get a point for these. Both these intervals are worth 1 point, and the reason is worth a point. And D, the point x equals 4 was 1 point, and the reason was 1 point. So there's your 9 points for FRQ 359. And there's your FRQs for the week. You'll have a quiz on Thursday, so check back if you have any questions on them, and we'll have a quiz on Thursday.